Matter makes up everything we can see in the universe, but how it behaves and transforms remains a real mystery. That is until now. This morning, Cole Miller, a member of NICER team, is joining us to talk a little bit more about this. Good morning, Cole. Thanks for joining us.
Thank you for having me.
Absolutely. So this is really interesting. What is really the difference between a black hole and a neutron star, and why are we talking about this?
Yeah, both of them come from the deaths of really big stars. When the star collapses, for a neutron star, it stops at about the size of a city and it has a surface. But for a black hole, nothing stops the collapse. It goes all the way to a point, and if you get too close to that point, you cannot come back at all.
And so I understand that y'all at NASA have been able to now see the moments right before the black hole becomes a black hole. Is that correct?
Yes, what we're looking at is a neutron star, the heaviest known one. So put some more stuff onto it and it can become a black hole.
Mm-hmm. And so how do we really study and look at a neutron star? Why is it important?
What we're doing here in NASA's NICER mission, this looks in X-rays. It means it has to be above our atmosphere because fortunately for human beings, X-rays don't come through our atmosphere. And so in studying the X-rays from this particular neutron star, we figure out how big it is, and doing that we get hints about what's inside.
Right. Now I know when we're talking about things like stars and space, the images we're seeing aren't necessarily in real time. Can you share a little bit more about that, and where are these images in time when we're looking at them?
Yeah, absolutely. This study had to take a few weeks of telescope time on the target, over 2 years of analysis. This is long, painstaking, but it's worth it in the end.
Why do you think it's worth it?
I think it's worth it because neutron stars have some of the greatest extremes of matter, energy, and gravity in the universe. And when we're studying it as a result, we're really getting to the heart of some extremely fundamental issues.
Mm-hmm. And talk a little bit about those issues. Why is it so important to learn about this stuff?
It's important because the matter inside a neutron star is something we can't study on Earth. There's just no way we can put it in laboratories. And so our understanding of the fundamental nature of physics relies on these types of analyses.
That's so cool. And then we learn about our own Earth here, right?
Yes, we do.
All right. What do you think would be your favorite in terms of studying? Do you think the black star am I saying it correctly? I forgot. Black hole
black holes.
Or the neutron star? Which one do you think is more interesting in the study of all this?
Yeah, that's a really tough one because black holes are amazing. But neutron stars have so many extremes, and I've been studying them since I was in a graduate school, so I think I have to give the nod to neutron stars.
All right, sounds good. If we learn a little bit more about out there, we learn a little bit more about in here. Thanks so much, Cole Miller with the NASA NICER mission. Thanks for joining us this morning.
My pleasure.